Good morning, friends. This is series of lecture for T.Y.B.Sc Analytical Chemistry students, semester 6, and the course of the subject is CH6 The chapter we are going to study is chapter number 6, flame emission spectroscopy. Now, in the flame emission spectroscopy, we have already learned about the introduction, principle, instrumentation part associated with the flame emission spectroscopy, qualitative analysis. Flame emission spectroscopy is useful for the qualitative analysis and quantitative analysis. Now, qualitative analysis, simply identification of the color, or you can say wavelength of the light, that gives the qualitative analysis, and the intensity of the color or the intensity of the flame is this information, that the intensity of the wavelength gives the information about the how much quantity of the element is present in quantitative manner, or you can say for quantitative analysis. Now let us see why the FES is popular technique. It has some reasons. So FES is a popular technique because of the following reasons. First, it gives a rapid method used for qualitative and quantitative analysis for elements. Now, FES is the method which is useful for the elements for qualitative and quantitative manner, or you can say for qualitative and quantitative analysis. So FES is used for the analysis purpose, for qualitative as well as the quantitative purpose. Now the second part is, it is a simple method and it requires a less time. So FES is a very simple method. Only a sample which is under study, it's a salt solution is prepared, and that is aspirated into the flame. We get the identification about the wavelength and the intensity, and from that analysis has to be done. So it is simple method and it requires very less time. Now the third point is that the popularity of FES. Environmental samples like soil, water and air can be determined in trace amount. So very trace amount is necessary for soil, water and air to identify the constituent, or to identify for the qualitative and quantitative purpose. Now the fourth point is that it is useful, it is used in medical field. So FES is used in the medical field. Generally, blood serum sample, urine sample can be analyzed by the FES, and therefore FES is used in the medical field. Now the fifth point is that it provides clean, rapid, reproducible and reliable and accurate determination. So simply, it provides a clean determination, it provides a rapid determination, it provides a reliable determination, it provides a reproducible determination, it provides accurate determination, and therefore for this reason FES is mostly used. Some non-metals like halides have to be estimated with their measurement of intensity, emitted intensity in the IR region. So non-metals like halides measured in the IR region that can be analyzed, or you can say non-metals like halides that can be analyzed by the FES. So these are the 6 points which is useful, or which are the basic reason for the popularity of the technique, that is FES. Now here, sodium and potassium samples that can be analyzed quantitatively. For this here, the paragraph that gives information about the sodium analysis. Sodium in the urine and serum sample is analyzed by the flame photometry. Sodium in urine sample is determined by diluting the urine sample 1:1000 and emission intensity of sodium is measured at 589 nanometer. So sodium has a wavelength 589, so which is standard one, and we measure the emission intensity at this, or can say we detect the sodium at this wavelength, so 589 nanometer. So this is important line. Sodium is just diluted in 1:1000 ratio, means 1 ml of urine sample that should be diluted to 1000 ml distilled water. So that is the proportion. The intensity is correlated with the intensity of standard sodium ion solution. So this is how the analysis has to be done by the flame photometry. That sodium in the urine sample and serum sample is analyzed by the flame photometry. Sodium in the urine sample is determined by diluting the urine sample in the ratio of 1:1000. So 1:1000 means 1 ml that should be diluted to 1000 ml. So 1 ml of the serum sample, or you can say urine sample, that should be diluted to 1000 ml distilled water. And its intensity, that is sodium, has a wavelength that is 589 nanometer. So we select the filter of that. The intensity is correlated with the intensity of standard sodium ion solution. We just measure the intensity, and from that intensity measurement we get the quantitative analysis of sodium. So the intensity is correlated with the intensity of standard sodium ion solution. Now similarly potassium is detected. Potassium in the urine and serum sample is analyzed by the flame photometry. Potassium in the urine sample is determined by diluting sample 1:1000, and emission intensity of potassium is measured at 766 nanometer. So potassium has a characteristic wavelength, and that is a 766 nanometer. Potassium is measured, its intensity is measured at 766 nanometer. The intensity is correlated with the intensity of standard potassium ion solution. And the last one, the technique is used in the agriculture for determination of fertilizer requirement of the soil. So soil is nothing but it is a combination of different types of the elements in major proportion, in minor proportion, and in micro constituent. So potassium and sodium, or you can say like Fe, cobalt, nickel, molybdenum, that can be also analyzed, which is the soil constituent of the So these elements that can be detected in the qualitatively and quantitatively in FES. So the technique is used in the agriculture field for the determination of needful proportion, to understand the needful proportion of the soil constituent. So it can also use for natural water analysis and polluted, or you can say wastewater analysis. So the technique is very useful. It gives the identification, it gives the qualitative as well as it gives the quantitative information. FES is useful for qualitative and quantitative estimation. Basically FES is used to analyze the potassium, to analyze the sodium in blood sample, or in serum sample, or in urine sample. So by this way we determine the concentration of the elements present in the sample by flame photometry. Again, the flame photometry is useful to determine the concentration for which are needful in the soil. So again, the method is useful for the natural water analysis and wastewater analysis. With this content, I conclude this lecture. Thank you very much for your patience listening.